Hi everyone, it's Sorkin. Today we are going to design a data structures for the least recently used cache, LRU cache. So we are given the capacity and we need to implement two functions, get function and the put function. In the get function we receive a key and we need to return value. If the key does not exist in our cache, then we are returning -1. In the put we are adding our key and value to our cache. Another important requirement is the functions get and the put must run with the constant time complexity. Okay, which data structure we are going to use in order to implement LRU cache? There are not much data structures that gives us constant time complexity. In this case, and since it's a cache, we are going to use hash table or hash map to store our key and value. Let's say that we have key as a 2 and the value as a 22. We added the next pair is key is equals to 3, value is equals to 33, and the key is equals to 4, and the value is equals to 44. And the next time, and the next element that we are adding again 2 with the value of 23, so we are updating 23. And let's say that the next one that we want to add is 5 and the 55. 5 and the 55, right? Key is being 5 and the value is being the 55. And let's say that our capacity in this case is equals to 3. So what's that mean? It means that we need to remove this 3, right? Because we added 2 first, then 3, then 4. Now we use the 2 one more time. So it means that the least recently used cache, least recently used key is 3. So we need to remove this 3, right? So we need to remove this 3 and before adding our 555 because our capacity is equals to 3. So how we can track it? So the way we are going to track it, the way we are going to implement that, instead of storing here values, right, values of our cache, we are going to store here the pointers to our N1, N2, and N3 to our double linked list. So we are going to implement the node, right, node class, which will have the key, which will have the fields of key, value, next, so the next node that it's pointing to and the previous node that it's pointing to, right? So for example, in this case, let's implement that. So how it's going to be implemented? So first we are going to create two nodes just to track our head and the tail. So let's just call it head, right? Our head. It will be pointing, the previous node of it is null, right? And also we are going to create a tail. We are going to create a tail, right? We are going to create a tail that will point also to null. The next is there is no elements because it's tail. And the previous of it is it points to our head and our head points to tail. So, okay. Now we are going to add, when we are adding our key and value to our hash map, we are also adding the node that is pointing to our double linked list. For example, let's say that the first we are adding 2, right? We are adding 2 and the 22. So we added here 2 and the 22, right? We are adding 2 and the 22. Every time when we are adding a new element, we are adding that element to the head, right? To the head of our linked list. So we are adding, so after our head will point to the element that we are just adding. So we are adding first to 22. So our head is pointing to 22, right? And let's say that now we are adding the next one. The next one is we are adding again 33. So we are adding that here, 3 and 33, right? We are adding that here. We are adding that here. And now we are adding the next one, 4 and the 44. Again, each time when we are adding that to the head, next to the head. So our element that when we are adding key value, we are adding that next to the head. So we are adding 4 and the 44, right? So it points to our our head points to the 444, and so they are pointing to each other here and here, right? Okay, so what happens next? What happens next is we are calling our put function one more time, and we are adding 2 and 23, right, with the updated value. So what we do here, we are doing following. We are removing this one, right, the pointer for this one for 2 and 22, right, and we are moving that to the head of our linked list, a double linked list. So now our head will point to 2 and 22, right? It will point to 2 and 22, right? It will point to 222 and 222, right? It will point to our 4 and 44. So now at the end of the list and the 333, it will point to our tail, right? It will point to our tail. And now if we want to remove, this is the last element, right? This is least recently used cache. Now in this case, this one is the least recently used cache. Now if we want to add the next element, we are checking the capacity. Capacity is equals to 3 because we have already our map has already 3 values, right? Our hash map already has 3 values, which means that we need to remove, and we need to remove the one that is previous to tail, right? So in this case, we are removing 333 because this is the least recently used cache, and then we are adding 5 and 55. So after removing this one, right? After removing this one, we can add 555 here. Then our head will point to 555, and the 555 will point to 2 and 22. So our get function and the put function. So in the get function, we are going to move the node that we are adding, or the existing node, to next to the head, next to head, right? To head. Every time when we are calling the get function. When we are calling the put function, we will always put that, okay, we also will move next to the head, as we are doing here. Okay, first thing to do, let's create our LRU cache, right? So let's create our LRU cache. It's gonna be map of integer and the node that we are going to implement in a second. So it's a LRU, let's call it LRU cache. Okay, it's a new hash map, and that's our LRU cache. Also, we need to set our capacity. So let's set our capacity int capacity that we are going to pass through a constructor. Let's also create our new current capacity that we are going to use, right? Current capacity. Okay. So, and the next one is, let's initialize our head and the tail. So our node is equals to, let's call it our head, and we are going to create a new node, which we are going to implement in a second. So we are going to pass here in the constructor -1, and the -1, we can actually copy paste this part, and let's call it tail, right? So we have a head and tail that will keep track of our tail. So that will keep track of our nodes. So now let's implement our node. Our node is, so node, it's gonna be of what? It's gonna be, so we will have, first we will have our key, we will have our value, and we will have our int node next, right? Previous, and we will have not int but just node previous, and also node next. Okay, and let's create a constructor for it. Constructor for it is node, where it's gonna take our int key, and it's gonna take int value, and let's initialize them. So our this key is equals to our key, and this value is equals to our value, and also this previous we are initializing to, we set to null, and the same for the next. This next also equals to null. Okay, all right. So now let's, in our constructor, right, we are receiving our capacity here, and let's also initialize them. Our capacity is equals to our capacity, whatever we are passing here. So our current capacity is equals to, our current capacity is equals to 0, right? We are initializing that, we are starting with the 0 current capacity, and also we are initializing our head. So for our head next, right? So we have our head here. So our head next, it's pointing to what? It's pointing to our tail, right? Our tail, and our tail previous is pointing to our head. Okay, so now let's implement our method. So let's first implement our, so we have our node here, right? And we have initialized our LRU cache. Now we can start to implement our get and the put method. Let's start first with the get method. So what the get method, what we are going to do, let's check that, let's actually, from our LRU cache, let's get our key, right? Get our key. So if we are getting our key, and it equals to null, right? What's that mean? It means that we don't have that key in our cache, so we can return -1 right away, right? So we can return the -1 right away. If we have it, then we are getting our node, right? We are getting our node, and so LRU cache get our key. So we are getting our node, and we are going to return that node, right? We are going to return that node value. We need to return the value, right? We set that the value here. Okay, value. Okay, so we are returning our value, but before returning our value, what we need to do, so let's say we have added 222, right? 222, and now we are adding 3 and 23, and we are updating again 223, right? So which means that we need to move that to the, so our head now should point to the 223 because we have just used that. So for that, we are going to remove our node, so like a remove node, right? We are going to remove node just for the convenience purpose. We are going to do that in 2 functions, which we are going to use in the get and the put function. So we are going to remove, and we are going to add node again. Okay, we are going to implement these 2 methods in a second. So we are going to add our node again. Okay, so that's it for the get method. And now let's do for our put method, right? So for our put method, we are again checking that if that key exists in our, hash map, in our LRU cache, right? So for that, we are LRU cache get, we are getting our key, right? If that equals to null, then in that case, what we are doing here, we are, if that is equals to null, then it means that if that is not equals to null, so it means that we already have it, right? We already have it. If that not equals to null, then we already have that, so we need to update our value. So to do that, we are getting our node here, our node, so LRU cache get our key, right? We are getting our key, and now we are just updating our value. So because we may, let's say that our previous value was 22, now we are updating that to 23, right? So we are setting the value here, node value, we are setting that to our value. And again, we are doing exactly the same operation as we did before. So we are, since we have updated that value, we need to move that after that our head, right? So we need to that to the beginning of our double linked list. So okay. So that's the case when it it's not equal to null, right? If it equals to null, which means that we don't have it, and we are just adding that to our cache. But to add it to our cache, first we need to check that if our current capacity is equals to our capacity, So if that equals to our capacity, what we need to do in this case, we need to remove the last, node that we have, right? The last least recently used node that we need to remove. So to do that, how we can find out that node? It's easy. We are taking the node and we are taking our tail, right? Whatever is the previous to our tail is our node that we need to remove, right? So we are previous, right? So previous one, we are taking that node, and we are going to remove that from our map, right? So our LRU cache, we are going to remove from our LRU cache, and we are going to take the node and the key, right? So we are taking the key and we are removing that from the LRU cache. And we are removing also from our nodes, right? So we are calling again remove node function, and we are just removing our node, right? We are removing our node. Okay. Now we can create, so we are removing that, and now we can add to our node, right? So now we can add our new node. So to do that, let's create a new node, right? Let's just call it a new node, and so we are calling a new node, and we are passing here our key. So we are creating a new node. So we are passing our key and we are passing our value. Okay, we have created a new node. So now we have to add node. So we need to call the add node function, which will add it to the beginning of our double linked list, right? So we are adding our node, and also we need to we are adding our node, and also we need to add that to our LRU cache, right? LRU cache. We are adding to our LRU cache, we are adding a key, right? And we are adding our new node. Okay, this is our put method, get method, and the put method or function. Now we need to implement our remove and add node functions. So right, implement our remove node and add node function. So let's do that. Let's first do private. So it's going to return void. We are just adding, and add node, right? Add node. So we are adding a node here. So we are taking our head next, right? Head next. our head next should point to our node now, right? Our head next should point to our node. But before that, we need to also take our, whatever our head is pointing right now. Head next, so head next, right? So let's just call it a node and call it head next, okay? So our head will point to our node, right? And our node should point to the head next, right? So our node previous will point to our head, right? Will point to our head. And also our node next will point to what? Our node next will point to our head next, right? And our head next previous will point to our node, right? That's it. We have added, so basically we are taking our node and we are adding that to the beginning of our double linked list where our head is pointing to that. Now let's do the same for void. Let's do remove node. For the remove node, what we are going to do here, we are going to remove that from the node and the point. So let's create two, right? Whatever on the left and the right of our node. Let's call it left. And let's call it left. What is on the left? Whatever is a node. So it takes the node here, right? It takes the node. So whatever node previous is, right? Previous is our left. And now let's take the node right. Whatever comes to right to the node, right? And it's our node next, right? Our node next. Now our left should point to the right, right? So what's that mean? It means that the left next is pointing to the right, right? And right previous, in that case, right previous points to the left. Okay, left next and the left next points to the right, and the right previous points to the left, and the left previous is, yeah, stay the same. Okay, that's it. Okay, let's run it. Okay, we need to correct here. It's a new node, and also we forgot to call here put function. Okay, and also every time when our current capacity is equals to capacity, we need to decrement our capacity, right? Because we are removing one node. And also every time when we are adding a new node, we need to increase our current capacity. We need to increment our current capacity. Let's run it. Okay, great. It works as expected. Let's calculate our time and space complexity. Our time complexity in this case is by requirement it should be constant, and both of our functions are constant, so it's of 1. And our space complexity depends on our capacity, so it's of n, because n is being the capacity. So because we have two structures, right, two data structures that contribute to our space complexity. One is the map, where our LRU cache, and another one is our node, our AA linked list, which can be at most the size of n. Okay, that's it. Let's go actually over it one more time. So what we do here, first thing that we did, we created a double linked list, a node that contains our key, contains our value, our previous pointer to our previous node, and a pointer to our next node. Then we are implementing our get function. So in our get function, we are checking that if that exists in our LRU cache, then if it does not exist, we are returning -1. If it exists, then we are removing that, and removing that the pointer to that node, and then moving that to beginning of our double linked list every time when we call the get function, and we are returning the value. When we are implementing our put function, we are passing key and value, and the first we are checking if it already exists in our LRU cache. Then what we do, we are getting that node, we are updating the value, and again we are moving that to the beginning of our double linked list. And if it does not exist, first we are checking the capacity, and if the current capacity is equals to capacity, which means that we need to remove a node before adding a node. So we are moving the node that is prior to our tail, because that's the least recently used node, least recently used cache. And then we are decrementing our capacity, and we are adding a node, and then we are adding a node and incrementing our capacity. And the two functions that we have implemented, the add node and the remove node, that we are using in both cases, in put and in the get function. Okay, that's it. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.